Alright, this is your second video going over the Unit 10 review. This is question number 4. This is where I left off from the first video. In this one, I would use quadratic formula. That method works every time, so that's typically my preferred method, unless I can factor it quickly. This one, it might factor, but it looks like it's a difficult one to factor. So quadratic formula is what I'm going to pick. A is equal to 10, B is 17, and C is 3. I'm going to plug those into the quadratic formula. I'll write it down again. Negative b plus or minus square root b squared minus 4ac all over 2a. Remember, if you come to class next time, you can get extra credit if you can recite the quadratic formula back to me. Alright, so I'm going to plug those in. Negative 17 plus and minus square root b squared, so that's 17 squared minus 4 times 10 times 3, and that's all over 2 times 10, so 20. I'm going to go ahead and insert what's underneath the square root. 17 squared minus 4 times 10 times 3. I'm getting 169. Square root of 169 is 13. So this simplifies to negative 17 plus or minus 13 all over 20. Negative 17 plus 13 is negative 4. Negative 4 divided by 20 is negative 0.2. So one of my roots is equal to negative 0.2. Negative 17 minus 13 is negative 30. Negative 30 divided by 20 is negative 1.5. Negative 1.5. Alright, those two numbers are going to be hard to find the middle of, so I'm just going to average those two numbers. If I do negative 0.2 plus negative 1.5, and if I divide that by 2, that's going to be the middle. It's the average of those two numbers. Okay, so negative 0.2 plus negative 1.5 is negative 1.7. If I divide that by 2, it's negative 0.85. So that's going to be where the vertex is located. This is the axis of symmetry, so I'm going to draw that in best I can. I'm also going to plot my roots. So 0.2 would be about right here. And then negative 1.5 would be about right here. And then negative 0.85 is my axis of symmetry. Switch colors, and that's at negative 0.85. So I'm going to go as close to 1 as I can. Okay, so this black line, that's my axis of symmetry. X equals 0.85. That's a negative number, though. Okay. Next thing, plug that in. So if I plug that into the equation, my equation was this 10x squared plus 17x plus 3. So I'm plugging in a negative 0.85 for that. 10 parentheses, negative 0.85 parentheses squared plus 17 parentheses negative 0.85 plus 3. And I'm getting negative 4.225. So I'm going to write down my vertex point. My exact vertex is negative 0.85, negative 4.225. This is the vertex. Don't forget that step. You always got to put the vertex point. 1, 2, 3, 4.25-ish. So right in that area. Okay, this is really steep because of this multiplier, so this is another steep one like the first question we did. And then the y-intercept is at 3. 1, 2, 3, plot a point. Reflect that over. This is 0.85 away, so it's going to be 0.85 on the other side of this line, so about right in that area. And now I've got 5 points that I can connect to make my parabola. Alright, I do need to write down my y-intercept right here so I don't forget. The y-intercept was 3, so 0, 3. And we went ahead and graphed and labeled everything. Okay, we're going to transition to the last page. Alright, we are on the last page here. Determine if the following tables are linear, quadratic, or neither. So the way that we do that, it's been a while, but we check how they're growing. So these are growing by 1 every time in terms of the x's. This is just a plus 1. So let's check to see how these are growing. So this is growing by, looks like it's just growing by 1. And then it's growing by, from 6 to 9 is 3. And then from 9 to 14, that is 5. So since it's not consistent, it's not linear. So don't say linear for A. And the way that you check to see if it's quadratic is you look at the second difference. So since it's squared, it's the second difference. And what's the difference of 1 and 3? That's a difference of 2. And from 3 to 5, that's a difference of 2. Since the second difference is consistent with it being 2, it doesn't have to be 2, it just has to be consistent, then this one is actually quadratic. Okay, let's try the next one. So in letter B, it looks like it is going up by 1 still. And then on this side, it's going down by 3. Down by 3, down by 3. It's consistent on both sides. It's going by 1 on the left and by -3 on the right, or on the y values, I should say, not the right. So this means it's linear since it's decreasing by the same value every time. Okay, so this one is growing by 1. So plus 1, plus 1, plus 1. And this is growing by, from -2 to -4, that went down 2. From -4 to -10, it went down 6. And from -10 to -20, it went down 10. And if I look at the second difference, is that the same? Because it's definitely not linear. So from -2 to -6 is -4. And from -6 to -10 is also -4. So yeah, the second difference is the same. So we would say quadratic. Okay, this one's increasing by 1, and then this one looks like it's growing by 3, growing by 2, and then growing by 3. Check that again. 3, 2, 3. That's not the same, so it's not linear. And if I check the second difference, this one went down 1, and then it went up 1, and that's not the same either. So this one would be neither. Okay, so make sure you can identify, looking at tables, if is it quadratic or not. If that's kind of confusing for you, you could graph the points and see if it's making a U shape or a parabola, right? Or a linear or a line. Number 6, identify which of the following is in standard form, vertex form, or neither. So this is standard form. So we're going to put standard form for that one, standard form. This is vertex form. It's important to know both of those. Those will be on the test at somehow. This is neither. This is actually how you find, it's another strategy for finding the axis of symmetry. And then this one is in standard form. Okay, number 1, on the multiple choice part, there will be some questions that are multiple choice, very similar to these ones. Which of the following represents the solutions to the quadratic equation? Roots are solutions, zeros are solutions, and x-intercepts are solutions. So the answer is actually D, all the above. Which of the following equations represents a quadratic equation? A quadratic is something that's squared, right? So this is B, it's a squared. What do we call the graph of a quadratic? That is a parabola. What is the vertex of the equation? So looking at the equation, the vertex would be 4, 14. 414. So A. Is the graph of the quadratic upward or downward? Since there's nothing in front, that means it's a positive in front. That's how you determine. So this one's going to be upward because it's a positive in front. Positive leading coefficient. Which of the following is a point on the graph of the quadratic? So what we have to do is plug these points in and see which one would be a point. If we were to plug 0 in, we would get positive 3. So this is not a point. If we plug 2 in, let's see. I'm going to take my calculator and plug 2 in for x. 4 times 2 squared minus 4 times 2 plus 3. That's 11. So that doesn't work. Okay, let's try the 3. So I'm going to insert the same equation but change the 2's to 3's. And I got 327, so yeah, this one is a point, so it should be C. I'm just going to do a quick confirmation by typing in the last equation and put a -1 in. So if I change the last equation, 4 parentheses -1 squared minus 4 -1 plus 3, I get 11, so yes, that's not right here. So it is just C. The last question, solve the equation using the zero product property. So this is where you set each factor equal to 0. So 5x minus 15 equals 0 and x minus 2 equals 0. On the one on the right, if I added 2, I would get 2 as an answer. And on this one, I would have to add the 15 over and then divide by 5, and I'm going to get 3. So it looks like 3 and 2 are the solutions. 3 and 2, so that's letter D. Okay, there is your answer key to the whole study guide. So here's the back page, and of course I had the front page already. If you have questions, please let me know. Thanks for watching, and I hope you found this helpful.